And he said, no, it was a horse's face, not yours. Oh, thanks, guys. Great way to start the day with a good joke. All right. Okay. So, what we did last time was we took our 45-degree angle and we did SOHCAHTOA with it, right? And CHOSHAKOW. Let's keep on going here. Let's jump to a 30-degree angle, okay? So what I'm going to do is I'm going to draw a triangle here. As close as I can to a 30, 60, 90 triangle. Look at that. Now here's a question for you guys, is what are the side lengths for a 30, 60, 90? When we were doing a 45, 45, 90, it was 1, 1, root 2. Johnny, you remember what we do on this one?
So the short side is x, and then the hypotenuse is 2x, and then the longer thing is x times the square root of 3.
Awesome. Good job, Johnny. Now to make this even easier, what we're going to do is let x be 1. Because then, this will just be 1, that will be 2, and that will be square root of 3. So I'm going to actually replace x with 1. And then, there we go. There's my triangle. Isn't that nice? Now, we are going to find SOHCAHTOA CHOSHAKOW of 30 degrees to start. What I need to do before I can do that is figure out which is opposite adjacent hypotenuse here. So, let's go to Amber. From 30 degrees perspective, how would you label 1, 2, and square root of 3 as opposite adjacent hypotenuse? Awesome. So what I want you to do is now go through with your group, and I want you to figure out what is sine of 30 degrees, cosine, tangent, then cosecant, secant, cotangent. And if you forgot, just look at SOHCAHTOA CHOSHAKOW on the sideboard. All right, let's do some fun here. Rayanne, you're going to do sine. Johnny, cosine. Chloe, tangent. And then we'll go to... Goodness, I'm drawing all the people who are missing. Valerie, you got cosecant. Kaylee, secant. And... Jennifer here today? J-Lo? No? So then Leva, you got cotangent. All right. So Rayanne, what did you get for sine? Awesome. Cosine is Johnny. Great. And then tangent, Chloe. Great. Let's go to cosecant with Valerie. Yeah, that's great. And then Kaylee for the secant. Yep, you're right. Don't be shy. So it's going to be the reciprocal of cosine. So just take this, and then, so it'd be 2 over what? Square root of 3. Great. And then lastly, for cotangent, Leva, which we'll just write like that. Cool beans? Okay, now, how do you check your work? Well, we're going to get your calculator. Let's just maybe check one of these, okay? Put in your calculator sine of 30. And it should give you 1/2 or 0.5. If it doesn't, it means your calculator is not in the correct mode. So you might need to change your mode from radians to degrees. For the 84s, that's pretty easy. You just push the mode button. You can change it. On the Inspires, it's a little more tricky. So if you don't have it, I can show you how to do that here in a second. But was everyone able to get sine of 30 is 1/2? Okay, now here's a question. How would I do cosecant? Because if I look on the calculators, I got sine, cosine, tangent. So how do we do reciprocal trig functions like secant, cosecant, and cotangent? Any guesses from you guys? Well, let me ask you this. What does it mean to be the reciprocal? In math, how do we take a reciprocal? You flip it, right? So if sine is 1/2, cosecant is just 1/sine. So what I would do is if I wanted to do the cosecant of 30, I would put in my calculator 1 divided by sine of 30. You just do the reciprocal of SOHCAHTOA. Okay? Now, good job. That was 30 degrees. We're going to do one more with 60 degrees now. So I'm going to change this so we're focused on 60. All right. So then how does that change our sides? Let's go to Natalie. How would I change my sides now for opposite adjacent hypotenuse if I'm looking from 60's perspective? So what do we expect to happen with all of our trig ratios if we go from the other angle? Let's see. We're going to go through and do the same thing now, but now we're going to be looking at 60 degrees. So let's take just a second longer here and do SOHCAHTOA, CHOSHA-COW. We're going to have Austin with sine, Mariana with cosine, Anthony with tangent, Gabby with cosecant, Griffin with secant, and Parker with cotangent. Okay, cool. So, Austin, sine, what are we going to get now?
Square root of 3 over 2.
Great. Mariana, cosine of 60. Great. And then Anthony, tangent of 60. Okay, good job. Keep going. Gabby, cosecant. Awesome. Griffin, secant of 60. And then lastly, Parker, cotangent of 60. All right. Okay, there you go. That's how we do SOHCAHTOA. And what's interesting is you can actually go and put that into your calculator, okay? Now, let me do one. This is actually going to be a problem we're going to do in a minute. Is it the next one or not? No. We're going to do it in a minute, but I want to do it right now since we're already talking about it, okay? Let's say I wanted to check sine of 60 on my calculator, okay? For those who have calculators, you all should. Put in sine of 60. Does it give you square root of 3 over 2? What does it give you? Ugly decimal. Now, how do I know that that ugly decimal is square root of 3 over 2? Well, I could put in square root of 3 over 2 and check it. Or watch this. Take that ugly decimal, highlight it, and then square it. So push enter so it copies it down and square it, or take the answer and square it. And what does it give you when you square that ugly decimal? 0.75. What is 0.75 as a decimal? So this squared is 3/4, which means if I take the square root, that 4 becomes a 2, and the 3 becomes a square root of 3. So do you see how you can match it by squaring it? Let me do one more, because some of you are like, what? Let's do tangent of 60. Will you go on your calculator and put in tangent of 60? and it's going to give you an ugly decimal. Now, instead of just plugging in square root of 3, take that decimal and square it, and what does it give you? Should give you 3, does it? That means that answer was square root of 3. You get what I'm saying there? Okay, cool, let's keep on going. Let theta be an acute angle such that the sine of that angle is 5/6. Evaluate the other 5 trig functions of theta. So on this one, it starts by giving us one trig ratio. It says sine of theta is 5/6. How does that help us? Yeah, it gives me sine is opposite over hypotenuse, so if it's 5/6, we got 2 of our sides. So I'm going to write this out. So if sine of theta is 5/6, well, that 5 is going to be my opposite, and 6 is going to be my hypotenuse. So not the greatest triangle, but there's a triangle. Let's assume it's a right triangle. And my opposite is 5. My hypotenuse is 6. Now, if I'm going to do all 6 trig ratios, what do I still need to figure out? How do I figure out the adjacent side?
36 minus 25.
So you're doing Pythagorean theorem, right, Johnny? Why don't you guys try to use a Pythagorean theorem here real quick? A squared plus b squared equals c squared for that third side there, okay? Okay, I got that b was square root of 11. Do you guys agree with that? I just did a squared plus b squared equals c squared, and that's how you get it. How come we couldn't use trig here? Well, we didn't know one of the angles. If we knew a side and an angle, then you could use trig, but since we were just given 2 sides, and since it was a right triangle, we could use SOHCAHTOA. So what I'm going to do is say that this side is now square root of 11. Well, hopefully you're getting pretty good at this now, because what you need to do is you need to go with cosine, tangent, cosecant, secant, and cotangent. But just to kind of give you a head start here, let's make sure we have the same sides, because if you do that wrong, you do the whole thing wrong. So James, from theta's perspective, how would you label our sides? Great, thanks James. So now you guys are going to go and get the rest of them. Let's get cosine, tangent, cosecant, secant, cotangent. And I'll call on some more of you. All right, so Edgar, you are going to take cosine. Ariana, you're going to do tangent. Christian, you're going to do cosecant. Amber, you're going to do secant. And Isabel, you are going to take cotangent. I'll give you a little bit longer to get there. Okay, Edgar, start us out. How did you do cosine? Great. Let's go to Ariana for tangent. Great. And then Christian, what about cosecant?
It's 6 over 5.
Yes, sir. Amber, secant. Great. And then cotangent, Isabel. All right, you guys guys are awesome. Do you have any questions on that? So instead of giving us an angle on this one, it gave us two sides, so we used the Pythagorean theorem and then did SOHCAHTOA CHOSHA COW. Feeling okay? Let's keep on rolling. We just talked about this. If I go on my calculator and I put in cosine of 30, it's going to give me an ugly decimal. Will you just tell me what that ugly decimal is, cosine 30? What is that ugly decimal? Blah, 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 right? And so what was the trick when you get that? How can you figure out what the exact value is? You square it, it's going to give you, was it 3/4? So then if I square root that, then I get that square root of 3 over 2. Okay? So that was kind of our trick. Because the calculators are good at reducing fractions, but not if they're irrational. They do have some of the newer calculators that will do that for you. Pretty cool stuff. But that's just a little trick if you need to know. Okay, I'm going to keep on rolling here because it's not too important. Okay, we're going to do a couple more triangles. I think we got 2 more and then we're done with this one. So great. This one they give you theta is 37 degrees. And they give you the hypotenuse is 8. And what you need to do is you need to figure out what A is, that is your opposite side, and then what B is, that is your adjacent. We've done this before, so I think you guys got this. So why don't I give you about 2 to 3 minutes here, and I want you to see how could I use SOHCAHTOA to help me solve for A and then B. The only clue is you have to do it individually. You can't do them both at the same time. So maybe start by finding A, and then go with B next, okay? Okay. Now, who has not been called on? I know you're going to try to hide and be like, you've all been called on, but who didn't I call on? I don't think I called on Hashira. I think I need to move your stick. Has everyone else been called on at some point today? I think so. I got to dig through these sticks and find Hashira. Did I already switch your stick over? Oh, there you are. Alright, so we're going to actually start with Hashira. You're going to help us find A. And then we'll put everyone's sticks back in, and then it's free game from there. Should be fun. Alright, so how'd you do this, Hashira? Let's look at A. Now, could you just say one more time, why did you use sine? Because that's the biggest struggle people have is they're like, well, how did you know it was sine, not cosine or tangent? Opposite hypotenuse. Perfect. Okay, keep going. Okay, cool. And then what does that give you? You guys agree with 4.81? Is it reasonable that that could be your answer? Sure, if the hypotenuse is 8, then that seems about right. It's good to just see if that answer would make sense. Alright, so there's A. Any volunteers for B? Or are we going to just open this up to everybody? Volunteers? Would be great is if we called pick Sheila again. What are the odds? Parker, how'd you get B?
So you take cosine 37. So it would be b over 8. Or yeah. And then you do the same thing, multiplying 8 to both sides. And cross it.
What does that give you for B?
You get a 7 is oh oops, one second. 6.389.
Cool, and does that seem reasonable? Looking at our side lengths, yes. We want to make sure answer is never bigger than the hypotenuse. Since that angle over here will be bigger than that angle, we expect the side to be bigger, which 6.39 is bigger than 4.81. Cool, you could always check your work with the Pythagorean theorem. With those decimals, you might be off just a smidge, but you'd be close. Cool, good. Do you have any questions on this? Then the last one, we're going to do just the same thing we've been doing, but now we're going to put a picture to it, which you're going to get more practice with things like this as well, so make sure you understand this. What I want you to do is read through it, highlight any key information, and then use a picture, label that information there, and try to solve it. I'll give you about 2 minutes here. Okay, Candy Bribery. I have a mini Hershey's Mr. Goodbar for someone who wants to do this for us. Valentine's Day edition. Anyone want some chocolate in the morning? Just tell me how you did it. Really? You're not speaking, this isn't speaking your language, Mr. Goodbar? Yes, Johnny's got it. Okay, how'd you do this, Johnny?
Okay, so the two side lengths